Sir, this is Sai Chirish and my teammates are Alisha, Arun and Maniteja. Today we're gonna demonstrate the two encryption standards, that is simplified data encryption standard and the advanced encryption standard. First of all, let's see the simplified data encryption standard. First of all, coming to AIM. AIM is nothing but to demonstrate the simplified data encryption standard using Python language. And coming to objectives, here we have mentioned about the HDS and the HDS algorithm. HDS algorithm is nothing but we'll pass the 8-bit plain text and we'll get the 8-bit cipher text as an output, and we'll perform these operations. By these operations only we'll get the output, that is the initial permutation, functions and the swapping and the inverse permutation. And we'll perform the key generation also, that is we will get the key1, key2 key for as an output for this. And this is about the simplified data encryption standard. Let's see the block diagram now. First of all, let's generate the K1 and K2 key. First, we'll pass the 10-bit key here and we'll apply the permutation 10 for this 10-bit key, and then we'll apply the shift operation, and then again we'll apply the permutation 8, then we'll get the K1 key here. Next, we'll perform the shift operation again here, and then we'll perform the permutation 8 here again, and then we'll get the K2 key here. This K1 and K2 key is used for the encryption as well as in decryption. Let's see the encryption now. First of all, 8-bit plain text is passed here, and then we'll apply the initial permutation here, and then the function key is applied here, and then swapping, and then again we'll apply the function key here, and then the inverse permutation is applied. Then we'll get the output as 8-bit ciphertext, and this will pass to the decryption as an input, and then we'll perform the initial permutation again, and the function key, and then the swapping and the function key again, and the inverse permutation again here, and then we'll get the output as 8-bit plain text. Now let's see the key generation. In key generation, we pass the 10-bit key which is provided in the question, and then we'll apply the permutation 10 for the 10-bit key, and then we'll get the 10-bit key, and the first 5-bit key we'll apply the circular left shift 1, and for the last 5-bit we'll apply the left shift 1, and then we'll apply the permutation 8 for this 2, and then we'll get the K1 as an output. And for the K2, we'll apply the left to shift 1, left to shift 2 for the left to shift 1, and then we'll combine this 10-bit key, and then we'll apply the permutation 8, and then we'll get the 8-bit key as an output. That is the K2 key. And this is about the key generation. And let's see the function block. In this function block, we'll pass the 8-bit plain text here, and we'll perform the initial permutation, and the last 4-bit is taken, and we'll perform the expansion permutation here, and then the output of the expansion permutation and the K1 key is performed by XOR, and then we'll get the 8-bit key. First 4-bit key is passed to S0, and the second 4-bit key is passed to S1, and then we'll perform the S0 and S1, and then we'll get the output as 2-bit key and here 2-bit key, and then we'll combine that and perform P4 for it, and then we'll perform the XOR for the initial permutation first 4-bit keys and the output of the P4. Then we'll get the 4-bit key as an output here, and then here we have a 4-bit key, right? That will pass here, and we'll swap this, and we'll apply the expansion permutation again here, and for the output of expansion permutation and K2 are applied by XOR, and then we'll get the 8-bit key, and the first 4-bit key is passed to S0, and the second 4-bit key is passed to S1, and then we'll apply the P4, and then the XOR with the first 4-bit key here, and then we'll get the output here, and we apply the IP inverse here, and finally we'll get the output as 8-bit ciphertext. And now let's see the code. Here this is a P10 value, that is P10 key, and the P8 permutation, and this is a left shift left shift 1 and left shift 2, and this is the initial permutation data and inverse permutation, and this is expansion permutation, and this is a swapping, and this is a P4, and this is a S0 matrix and S1 matrix. Let's see the key generation now. First we'll pass the 10-bit key here for the temp. We'll store it in the temp, and then we'll perform the S1 for the left shift 1 for the left 5-bit keys and the right 5-bit keys, and then we'll get the K1 key here, and the same we'll perform for the K2, and then we'll get the K2 value. From here Arun will continue.
Hi, this is Arun Kumar, and coming to function block, there are left block and right block, and using the temporary functions, and we use this code. And there are S0 out and S1 out, and we use these functions. And there are many temporary B3, B4, B5, and B6. And this is the encrypt function. We here we take input as K1 and K2 key generation, and we use temporary B1, B2, B3, B4 functions here to encrypt the code, and this is the decrypt function, and we use key generation K1 and K2, and we use here the temporary B1, B2, B3, B4, and we got the decrypted code. This is the plain text. We take it as an example, and this is the key, and this is the encryption function and decryption function. The output is as key. We given key as key 1 and key 2 to 8-bit codes, and we got it at 8-bit ciphertext, this like, and this is the 8-bit plain text. And the main key points for this code is it is a block cipher, and it has 8-bit block size and plain text of ciphertext. It uses 10 bits of key size for encryption, and it is a symmetric cipher, and it has 2 rounds. Thank you.
Hi, this is Alisha. Now I'm discussing about AES. First, let us start with the aim. Our aim is to demonstrate the AES implemented using Python language. And coming to our objectives, our first objective is how does AES work, and then we'll discuss about the AES algorithm, which consists of like subbyte, shift row, mixed column, add round key, and then we'll discuss about key expansion, and then encryption, decryption, and we'll also discuss about the implementation of the AES round on modern processors. First, let's go to how does AES work. The AES algorithm uses a substitution permutation or SP network with multiple rounds to produce ciphertext. In each of these rounds, it requires a round key, but since only one key is inputted into the algorithm, this key needs to be expanded to get keys for each round, including round 0. Coming to AES algorithm, each round comprises of 4 steps: subbytes, shift rows, mixed columns, add round key. When coming to the subbyte, in this first step, the bytes of the block text are substituted based on the rules. And coming to shift rows, in this step, just as it sounds, each row is shifted a particular number of times. In this first row is not shifted, the second row is shifted once to the left, the third row is shifted twice to the left, the fourth row is shifted thrice to the left. Coming to mixed columns, this step is basically a matrix multiplication. Each column is multiplied with a specific matrix, and thus the position of each byte in the column is changed as a result. Add round key, now the resultant output of the previous stage is XORed with the corresponding round key. Coming to key expansion process, in this, round keys are derived from the cipher key using the AES key schedule. AES requires a separate 128-bit round key block for each round plus one more. In this, we'll discuss about the AES key scheduling. We'll discuss about the efficiency, symmetry, diffusion, nonlinearity of the AES model. And coming to implementation of the AES round on modern processors, Different steps of the round transformation can be combined in a single set of lookup tables. This allows very fast implementation on processors with word length of 32 or greater. Coming to diagram explanation, here we explain the encryption process and decryption process of AES. Coming to encryption process, it is like transforming plain text to ciphertext, and decryption is like transforming ciphertext to plain text. In this process, we will supply the keys, and here we mention the steps in each round. Substitution of the bytes, as I already explained it. Shifting of the rows, here we use the some formulas like 1 circular left shift, 2 left circular shift, and 3 circular left shift. And third step, mixing the columns. Here we use the formulas to jumble up the message more by mixing blocks columns. We use these four formulas. And coming to add the round key process, in the final step, the message is XORed with the respective round key. When run repeatedly, these steps ensure that the final ciphertext is secure. And the code part is explained by Maniteza.
Hello, this is Maniteja. Here it is the code of simplified advanced encryption standard. And moving to the code, here we defined a function called key expansion, which has the parameters key, number, round, RCA, and SBox. Here round construct is equal to RCA num round minus 1. And going to the next page, here for I in range 4, u equal to hex and something we given, and then we define the function like this. We define the function of key expansion like this, and then we define the function add round key. It is having the parameters point and okay, for I in range 4, for j in range 4 x equal to 0, y equal to 0. And also we define like this function, and after we define the function substitute point SBox, and after that we defined a function shift row pt, and we defined a function mix column, mix multiplication column, and the parameters are column multiply 2 multiply 3. And then we defined a function print matrix m, and finally we given this code for this. And this is the output of the above code. Here we enter the plain text in multiply of 16 bits, and also enter key in multiply of 16 bytes. Initially it is like this, and then initial plain text matrix is like this, and initial key matrix is like this, and then round 0, after round 0 add key, this round 1, this round key, after substitution, after shift rows, after mix rows, after add round key. This is the whole output we got. And finally here the key points of the simplified advanced encryption standard. Advanced encryption standard is a block cipher. The key size can be 128, 192, 256 bytes, anything. Encrypts data in blocks of 128 bits each. Security strength greater than or equal to 3ds. The order of INV shift rows and subsets is indifferent. The order of add round key and mix rows can be inverted if the round key is adapted accordingly.